On slide 64, I'm going to show you kind of two ways to do this problem. One, the Gaussian method way, and then I'm going to show you another way just in case Gaussian method isn't quite working for you or you just get stuck and you need another option. So here we go. The Gaussian method again, remember, is to first get this into a triangular matrix and then solve it. So let's go ahead, and first step we want to do is eliminate our x out of one of the equations. So, this one's already set up, equation one's already set up to have a 1x, so that looks like it should still stay just our first equation always. So I'm just going to write that right down here, because that is our first equation, and it's not going to ever be replaced with anything. It's just going to be that equation right there. Now what I'm going to do is I'm going to eliminate the x out of equation 2. So the easiest way to do that is to say, okay, I have an x and I have a 2x. If I multiply this equation once, if I take and multiply -2 times equation 1, and then I add that to equation 2, and then replace that, whatever I get, to equation 2. So I replace it with equation 2. So in other words, I'm going to take -2 times this first one. So I'll put parentheses here, put a -2 right here, and we're going to distribute in, kind of just like that. That's going to give us -2x minus 4y plus 4y equals -2. So -2 times x, -2x, -2 times 2, -4y, -2 times -2z plus 4z. I don't know what the heck I'm thinking there, folks. It's early in the morning. Just kidding, it's not that early, but we're just kind of crazy. Then that should have been -2, because -2 times 1 is -2. Okay. Now I have this equation 2, because equation 2, nothing, I didn't do anything to it. Notice I just multiplied equation 1 by -2. So I get 2x plus 2y minus z equals 6, and I go ahead and I add those together. These are going to cancel. It's going to give me -2y plus 3z equals 4. Okay, I'm so close here. I just need to get this y to be a 1. So, or I not the y, but the -2 here to be a 1. So how could I get and make -2 become a 1? Well, I could divide everything by -2. And division in math is the same thing as multiplying by 1 over the number. So what I'm going to do is I'm going to take -1/2. I'm going to multiply it to equation 2 now. So remember, this now is my equation 2. And I'm going to then replace that with equation 2. So it's going to become my new equation 2. So basically what I'm going to do is I'm going to take this equation right here. I'm going to multiply by -1/2. So I distribute it in here, here, and here. So -1/2 times -2 is just y. -1/2 times 3 is -3/2 z. And -1/2 times 4 is -2. So there's my second equation. Y minus 3/2 z equals -2. Okay? So that's my new equation 2. This is now equation 2, and I wrote it right there. So now the last thing I need to do is I need to get this last equation, equation 3 here. I need to eliminate it and get it down to just z. So equation 1 is right here. My new equation 2 is here, and I used equation 1 to help me get there, and then multiplying to get there. So now I can use whatever ones I want. So I'm thinking I'm going to use equation 1 and equation 3 to eliminate first the x's. That's the first thing I'm going to eliminate, is the x out of this equation 3. So the way I would do that is I would take -3 times equation 1. Then I'm going to add that to equation 3. That's going to become my new equation 3. So now instead of multiplying by -2, I'm going to multiply by -3. And I'm going to distribute that guy in. So that's going to give me -3x minus 6y plus 6z equals -3. Okay, all I did is I took -3 times equation 1. Negative 3 times equation 1 gives me this new equation here. I'm going to then take equation 3, which is this one right here. Notice it's just equation 3. So 3x plus 4y minus 3z equals 5. And I'm going to add those two together. Add those two together. So this will cancel. Gives me negative 2y plus 3z equals 2. So my new equation, and this is now my new equation 3. So my new equation 3 looks like this. Negative 2y plus 3z equals 2. Now, here's equation 2. If I were to multiply equation 2, so if I were to take equation 2 and multiply it by 2, so if I take 2 times equation 2, all right, and then add it to my new equation 3, and then replace that with equation 3, I would eliminate the y's. So if I take 2 times equation 2, here's equation 2. So I'm going to take 2 times this. So that's going to give me 2y. 2 times negative 3 halves would be a negative 3z, because this is like 2 over 1. So it'd be negative 6 over 2, which reduced down to negative 3, equals negative 4. And now I take equation 3, which is this guy right here. Negative 2y plus 3z equals 2. We add those together. This cancels. This cancels. We get 0 equals negative 2. Okay, that's a problem. When we get them down to a 0 equals negative 2, do you remember earlier on what I said? What happens when you get 0 equals a number? You get 0 equals a number, that is no solution. That's no solution. Okay? Now, I told you I was going to show you another way to do this problem, which I will. All right? I'm going to show you right now how to do this problem another way. I'm just going to copy it down real quick. So we have x plus 2y minus 2z equals 1. We have 2x plus 2y minus z equals 6. And we have 3x plus 4y minus 3z equals 5. So there's our equation again. All right, this is known, my wife calls this the diamond method. But basically what you're going to do is the first thing you're going to do is you're going to take 2 equations. Now, UVU really wants you to do the Gaussian method because it's leading up to what we're going to be doing coming up pretty soon with matrices. But this is another way to solve, okay? You're going to take 2 equations, doesn't matter which 2, 1, 2, or 3. Take 2 of them, and you want to try to eliminate a variable. And you do the easiest ones possible. So to me, it looks like it'd be very easy if I subtracted these 2 together. So if I took these 2, okay, and I probably should have put that in the middle. It would have been easier to show you the diamond here. But if I bring those right down here, and if I were to take x plus 2y minus 2z equals 1, and I'm going to subtract 2x plus 2y minus z equals 6. So I subtract that. So x minus 2x is a negative x. 2y minus 2y cancels. Negative 2z minus a negative z, it's a negative z, equals 1 minus 6, which is negative 5. So now I have one equation right here with two variables. I now have to take the third equation, and it doesn't matter with which one here I do. It could be this one or this one. It doesn't matter. But I need to eliminate the y again. Because I eliminated the y over here, I need to eliminate the y again. You know what? Maybe I want to eliminate from the top. So I'm going to take and I'm going to multiply. So what I'm going to do is I'm going to take these 2 equations here, the first and the third. I'm going to bring it right over here, and I'm going to eliminate the tops, or the y's again. The only way to get the y's to eliminate here would be if this 2y and this 4y were either exactly the same or opposites. I'm going to multiply this one then by negative 2. By so doing, that gives me negative 2x. plus 4z, sorry, plus, it should be negative 2x minus 4y first. Gotta remember that minus 4y right there. Minus 4y plus 4z equals negative 2. And the bottom equation is 3x plus 4y minus 3z equals 5. Now I'm going to go ahead and add those together. So these will cancel. This gives me just x. This gives me z. And that equals 5 minus 2 is 3. So now what I'm going to do is I'm going to take these two equations here. I'm going to bring them together. And we're going to eliminate. So I have negative x minus z equals negative 5. And I have x plus z equals 3. Now to eliminate, I just need to add those together. These will cancel. These cancel. That gives me negative 2, and I get 0 equals negative 2. Again, there lies our problem. The reason my wife likes to call this the diamond method, if you look, sorry, I kind of got off the paper there. But if you look, it kind of makes a diamond here. At this time down here, normally you would solve for just one variable. Once you solve for that one variable, you would back substitute. Either you'd back substitute it here to get, like either you back substitute into here or back substitute into here to get the second variable. Then you take those two variables, back substitute up into the top to get your third. But again, since we get 0 equals negative 2, this again is no solution, just like the other page, okay? Hey, I hope that helps, and hope you guys have a wonderful day. I think I might do one more video on slide 68, so look for that to come. All right, we'll see you later, taters. Have a good day.